We are staring at a ghost in the radar clutter, a machine that defies the accepted laws of geopolitical gravity.
Imagine a fighter jet that slashes the operating cost of an F-35 by 50%, yet generates a thermal signature so...
We are not building a clumsy Frankenstein hybrid here. We are simulating a
This isn't just a midlife upgrade. It is a revolution in aerospace doctrine. It is the nightmare scenario that keeps defense planners awake at night. Today on AirDom, we run the ultimate what-if simulation. We are going to inject the world's finest engine into the world's smartest fighter to answer one question. To understand the sheer magnitude of this theoretical integration, we must strip away the paint and look at the raw engineering philosophy.
From its inception, the Gripen E was never designed to participate in the heavyweight lifting contest that defines America.
The vision driving Swedish engineers was far more radical. They sought to deliver maximum combat capability.
The doctrine is total defense, maximum lethality, minimum expense, minimum manpower, and zero dependence on vulnerable infrastructure.
The current iteration of the Gripen relies on a reliable, American-sourced General Electric F414 power plant.
Rolls-Royce doesn't just build engines, they weaponize thermodynamics.
In this simulation, we are stripping out the GE heart and transplanting a British masterpiece, the Blisk.
Forget the archaic methods of bolting fan blades to a central rotor that is a heavy, structural liability waiting to snap under 9G torture.
Rolls-Royce forges the blade and disc from a single, solid, unbreakable monolith of titanium.
When you inject this British DNA into the Gripen's featherweight carbon composite frame, you don't just change the specifications, you break the math. The result is a thrust-to-weight ratio that allows the aircraft to claw vertically into the stratosphere, leaving heavier,
This theoretical Gripen Blisk hybrid isn't just a fighter jet, it's a statement.
It redefines the cost-benefit analysis of air superiority, offering a potent counter-argument to the notion that military power
And its thermal signature, drastically reduced by advanced thermodynamic engineering, makes it a ghost, not just to radar.
This isn't just an engineering marvel. It's a geopolitical game-changer, potentially democratizing air power. The invisible warplane, a testament to what happens when innovation truly breaks the mold. What do you think? Let us know in the comments below.
Let us analyze the sheer lethality that this configuration offers.
The primary advantage here is the concept of Supercruise on a budget.
While fifth-generation heavy fighters must burn through massive amounts of internal fuel to maintain supersonic speeds,
A Rolls-Royce optimized Gripen E could theoretically sustain Mach 1.2 or higher without ever engaging afterburners.
This is the holy grail of kinematic performance.
It means the aircraft can transit to the battle space faster, imparting significantly more kinetic energy to its beyond visual range Meteor missiles at the moment of launch.
a missile launched at supersonic speeds has a longer no-escape zone, making the Gripen deadly long before the enemy even knows it is there.
But the true genius lies in thermal management.
Modern aerial warfare is increasingly fought in the infrared spectrum. In this arena, heat is an instant target lock.
A massive engine generating massive thrust is a beacon for every infrared search and track system and heat-seeking missile in the theater.
Rolls-Royce has spent decades perfecting the art of the cool-running engine.
By optimizing the bypass ratios and utilizing advanced ceramic matrix composites in the hot section,
This creates a form of thermal stealth. Thermal stealth.
You do not need the maintenance-heavy, radar-absorbing coatings of a B-2 bomber if your enemy cannot acquire a heat lock until it is too late.
This capability fits perfectly into the Gripen's
guerrilla warfare doctrine. Imagine a fighter that can fly low, utilizing terrain masking, with an infrared signature so faint it blends into the background thermal noise of the Earth.
It pops up, fires a Meteor Missile, and vanishes before the enemy's thermal sensors can distinguish the engine plume from the ambient air.
Now, consider the logistical revolution.
The Swedish doctrine demands that their air force can operate from highway strips, dispersed across the forests.
We are analyzing an engine designed for durability and modularity. In a high-intensity conflict, where specialized
The current Gripen is excellent at this. A Rolls-Royce powered Gripen would be unmatched.
The reliability of this propulsion system translates directly to sortie generation rates.
This is a metric that often gets lost in discussions about top speed and turn rate, but it is the metric that actually wins wars.
If Country A has 100 heavy stealth fighters, but can only keep 40% of them airworthy due to complex engine maintenance, and Country B has 100 Rolls-Royce Gripens with an 85% availability rate, Country B controls the sky.
It is a simple game of numbers.
This engine upgrade would extend the time between overhauls, reduce the wear on critical components during high-G maneuvers,
and allow air forces to generate more air power with fewer airframes.
Let us pivot to the economic warfare aspect of this simulation. The reality for most air forces today is brutal. They are bleeding cash.
The American F-35, the current market leader, costs upwards of $36,000 per flight hour to operate.
The Eurofighter Typhoon hovers around $20,000. Even aging fleets of F-16s are becoming prohibitively expensive as airframes fatigue.
The Gripen E was already the cost efficiency champion.
With a Rolls-Royce package focused on fuel economy and component longevity, we could be looking at a flight hour cost that dips,
potentially rivaling the operating costs of advanced trainer jets while delivering premier frontline performance. Fuel burn is the primary driver of daily operating costs. By refining the combustion cycle and optimizing the digital engine control software, Rolls-Royce extracts more Newton-meters of thrust from every drop of jet fuel. This extends the combat radius of the Gripen, a critical factor for a light fighter. It allows it to loiter longer, patrol further, and strike deeper. But superior engineering is useless if your fighter jet refuses to start because a politician in Washington said no. This is the dark reality of the black box. We must address the geopolitical implications of the engine switch. Raw performance means nothing if you don't own the keys to the ignition.
Engine comes with a chain attached, known as ITAR. A Rolls-Royce core cuts that chain. It makes the Gripen truly sovereign.
For nations in the global south, this isn't just a feature, it is independence. It offers a fighter jet that answers to no foreign capital, is immune to sanctions, and remains unreachable by diplomatic blackmail. This is a massive strategic disruption.
There is a vast market of nations, from Brazil to India to Southeast Asia, that want advanced Western avionics and
a Rolls-Royce powered Gripen E offers them that freedom. The ability to source parts and support from a European consortium rather than a single superpower creates strategic resilience. Let's put you in the cockpit to see what this really means. Nordic Winter, 2030.
An aggressor force of heavy flankers pushes across the border, their radar screening for main air bases.
But you aren't at an air base. You are hidden on a frozen highway strip, flanked by pine trees. Scramble. The Rolls-Royce core, optimized for brutal cold starts, screams to life and gets you airborne in under 400 meters.
You don't climb, you sprint. Utilizing the engine's passive thermal efficiency, you stay cold against the frozen background terrain.
The enemy's infrared search and track systems are sweeping the horizon for a hot jet plume, but you are a ghost. Pop up, unleash a Meteor Missile from beyond visual range, and before their warning receivers even scream, you've already turned cold.
By the time their counterfire arrives at your last known position, you are gone, aggressing at Mach 1.2 without touching the after. The Gripens land on a highway strip 50 kilometers away from their takeoff point. Ground crews refuel and rearm the jets in 15 minutes.
The engines, robust and tolerant of debris, handle the rough runway without complaint. They are back in the air before the enemy intelligence cycle can even identify where they landed. This is the loop of turn, burn, and return. The efficiency of the engine allows this tempo to be sustained for weeks. The enemy, flying heavy, maintenance-intensive jets, begins to suffer mechanical attrition. Their sortie rates drop. The efficient fighter begins to dominate the airspace simply by being present when the opponent is grounded. This scenario highlights a fundamental truth of aerial combat. Logistics is the ball and chain of air power. The Rolls-Royce upgrade also opens the door for future energy generation requirements.
We are moving into an era of directed energy weapons, lasers and high-power microwaves.
These systems require massive amounts of electrical power. A next-generation engine core is not just about thrust. It is about power takeoff.
The Rolls-Royce engineering pedigree suggests a design capable of generating surplus electricity to power the massive...
This future-proofs the airframe, ensuring it remains relevant well into the 2040s and 50s. Critically, we must look at the human element. Training costs are the silent killer of Air Force budgets. An engine that is forgiving, easy to handle, and cheap to fly allows pilots to log more hours. There is no substitute for time in the cockpit. A nation operating a fleet of F-35s might be forced to limit flight hours to save money, relying heavily on simulators. A nation operating the Rolls-Royce Gripen can afford to have its pilots in the air, mastering the physical sensations of flight. The efficient engine creates better pilots.
The competition knows this. The manufacturers of the Rafale, the Typhoon, and the F-35 are watching this potential evolution with unease.
The Gripen E, in its standard configuration, is already a nuisance to their market share.
A Gripen E that is faster, stealthier in the thermal spectrum, cheaper to run, and free of American political strings is a nightmare.
It exposes the inefficiencies of the legacy aerospace mindset.
It proves that you do not need to bankrupt a nation to secure its skies.
Ultimately, the fusion of the Gripen E and Rolls-Royce technology represents the triumph of intelligence over brute force.
It is a validation of the idea that better engineering can solve strategic problems that money alone cannot. It challenges the notion that bigger is better and replaces it with smarter is deadlier.
This aircraft, in this configuration, stands ready to rewrite the rulebook. It offers a glimpse into a future.
You engage with the channel. We are building.
Stay sharp.